Well, the question is, a particle moves in one dimension from rest under the influence of a force that varies with distance traveled by the particle as shown in the figure. The kinetic energy of the particle after it moved through 3 meter. So that is 3 meter. So we know that work done is nothing but integration of F dot dr, no? So which is equal to area under F R graph, okay? Area under, yeah, F distance graph, F versus S graph. And work done is nothing but change in kinetic energy. Work done by all the forces equal to change in kinetic energy. So here only one force is there. So change in kinetic energy also like that only. So it is nothing but kinetic final minus kinetic initial equal to area under graph. Area, this part is a rectangle only, no? So 2 by 2. Okay, height is also 2. That length is also 2 only. It is square. So 2 by 2. And this part is a trapezium, no? So this part will be what? Half into sum of the parallel sides. Okay, so this height is 2 and this height is 3, and the gap between them, it is 1 only. Okay, so that is 4, that is 3, so equal to 7. And the initial kinetic energy is 0 because the particle initially was at rest. So half into mass is okay, we need to calculate the kinetic energy only, not speed. So simply kinetic energy we need to calculate. So that is this part is actually half into base into altitude, no? So that is 2. Okay, 2 plus 3 plus 2, 5, 5 by 2, 2.5, 2.5. So answer is 6.5. So kinetic energy is what? 6.5 joule. So out of the 4 options, C option is correct.